Now that we've gone through all the mechanics and done one example to death through the 3 sections, let's focus in on a couple more examples comparing 2 proportions. And here I'm going to present the results using Stata, but if you want, you can actually try and replicate them by hand, just for the fun of it. But we'll focus on the interpretation here. So here's an interesting one from a study, an outbreak of gastroenteritis in a Maryland high school. So this is one of those real-life epidemiological studies where they're trying to figure out whether there's a culprit in a foodborne illness. The authors looked at a sample of 263 students who bought lunch on a single day, the day of the outbreak in question. Some ate sandwiches, others bought other meals. And here's a 2-by-2 table that looks at a cross-tabulation of whether or not the student who bought lunch in the sample ate a sandwich or not, and whether or not they came down with gastroenteritis. Here are the sample proportions and 95% confidence intervals with illness for the sandwich and non-sandwich groups, respectively. So the first one, using the CII command, roughly 48% of those who bought a sandwich in the sample got sick, as compared to 11% of those who bought something else. And you can see that the confidence intervals don't overlap, indicating that there might be some distinction in the proportion between the sandwich eaters and non-sandwich eaters. But of course, if we actually wanted to estimate the difference in those affected between the 2 groups and put confidence limits on it, we'd need to go to the 2-sample comparison approach and use the CSI command. The observed difference in proportions, that estimated risk difference, was an absolute 38% more students who ate sandwiches got sick than those who ate something else in this sample. But of course, the sample of people who did not eat sandwiches was relatively small, so there's some uncertainty here. But even after accounting for that sampling variability, suggests that this absolute difference in proportions could be as small, quote unquote, as 26% or as large as nearly 50%. And of course, that confidence interval for the difference does not include 0, and if we went and took the hypothesis testing approach, we get a p-value of, Stata reports 0.0000. What we have is a very low p-value that would be statistically significant even at the most conservative of thresholds, but certainly at the 0.05 level. So in this type of epidemiological study, this type of analysis was used to isolate the sandwich as the probable vector of the gastroenteritis that the students came with on that day. Recall this example we worked with before. Let's put it all together in a country-by-country comparison. We were looking previously in Lecture 3 at an example looking at the proportion of dialysis patients with national insurance in 12 countries, where we had samples of such patients collected from each country. And again, I have this snippet that shows 6 of the 12. Suppose we wanted to compare the proportion of such patients with national insurance between Canada and France. Well, here are the observed proportions and 95% confidence intervals for the proportion of such patients with national insurance in Canada and France, respectively. So in Canada, roughly 72% of the dialysis patients in the sample had national health insurance. And when we account for sampling variability, the confidence interval ranges from nearly 68% to 76%. Compare that to France, where 46% of the sample had national insurance, and after accounting for sampling variability, we estimate that the true proportion could be 41 to 50%. So again, these confidence intervals don't overlap, indicating that there's likely a difference at the population level, even after accounting for errors in our sample. If we wanted to get a p-value for that and actually quantify the uncertainty in the difference in proportion of insured such patients, though, we would need to approach it with the 2-sample comparison. So here's the data set up into a 2-by-2 table, which we can then feed into Stata with the CSI command to get a confidence interval for the difference in proportions and a p-value. And here are the results. The absolute difference in proportions of such insured patients in the sample, Canada to France, was 26%. After accounting for sampling variability, the lowest that could be by our confidence interval is 20%, and the highest is 32%. So even in the lowest scenario, it indicates that 20% greater absolute proportion of Canadian patients have such health insurance when compared to such patients in France. And the chi-squared here, the discrepancy measure is nearly 70, and that leads to a p-value that's very small as well. So again, we have a statistically significant difference after accounting for sampling variability in the proportion of such patients in Canada versus France.